Good noon, everyone, or 12:01 p.m. Let's go ahead and get things started. Welcome to the Kansas Association of Mappers first Lunch and Learn of 2022. I am your MC, Amy Roust. I'm the Education Committee Chair as well as the current CAM President. Just want to remind everybody before we get started that our current educational needs survey for the year is still open. And if you look in the chat window, you'll see the link to that. So let us know what you're interested in learning this year. And the results of that survey drive what we get organized in terms of classes and webinars just like this one. So please make sure that your needs are heard so that we can make sure to offer things that will help you. So today I'd like to introduce Bert Meyer of Trek Design. Bert is the lead developer for Trek's waterspout online platform for real-time Internet of Things water monitoring devices. He brings 30 years of GIS experience ranging from data creation to application development. Bert has provided GIS service for municipal government, public works, water, wastewater, and railroad applications. He's an expert in most Esri software and numerous programming languages to automate GIS data processing and deliver GIS applications to clients. He's also experienced using Microsoft SQL Server and MySQL to create and maintain databases for application development, reporting, and data management. Today, Bert is going to talk to us about using the ArcGIS JavaScript API for mapping sewer flow monitoring sites. Bert, take it away.
Wow, that was quite an intro. Thank you. I hope everybody can see this PowerPoint that we're looking at now. So this is just kind of what the agenda for today. I'm going to show you what the waterspout platform looks like, what it is, and then how we integrated some ArcGIS mapping into it, and then how that evolved into creating what we are calling our flow monitoring dashboard. Then we'll get a little technical and I'll show the part of the API, the ESRI request in particular, that allows you to pull data from a remote server. And I'm using it to call PHP functions, which call MySQL stored procedures. Then I'll show how I integrated the chart.js JavaScript library to do some charting in the dashboard. And then I'll show an application I wrote to help other users to configure the maps that go into waterspout, and then I'll show virtual rain gauge application. So this is actually direct from our website. I'm not going to read it to you, but this is what waterspout is. And to give you some background, this is a platform that we have purchased from someone, and we are adding a bunch of stuff to it. So there are a number of other companies that have purchased this flow monitoring software, and they basically municipalities and other people contract with these companies to put flow monitors in the sewers, and then we have termed this waterspout. There's other terms in the industry that people have used for this software platform, and so we have called ours waterspout. But so then people hire you to put flow monitors in and record the data, and then they have this platform so they can look at all the data. So I'm just going to start showing you waterspout. So first, obviously, you got to log in. And there's a bunch of configuration behind the scenes. Each login has a certain number of projects, that they're attached to. And so I'll just open up this one for Carl Junction. And what it is, this is a lot for engineers. So engineers, they want to graph things and look at data, and then you can configure monitors and different channels of monitors. So these are sites where a monitor is in the sewer, and then there's different channels of data that the sensors can give. Obviously battery, because it's a standalone unit, so you want to know how the battery is doing. And then the big ones are depth and velocity. And then we also have cameras, so we can actually take images, and all this data you can configure how often this data gets pushed back through telemetry, back to your server, back to our waterspout backend server. And it depends. Sometimes it's 5 minutes, sometimes it's half an hour, sometimes it's every hour. So, and this graphing is the Flot. Flot is another JavaScript graphing engine. And so the user will just come in and select some things, and then they can select a time parameter, and then they can graph, and there's the graph, and you can hover and see. And this is all part of the plot graphing, and this is pretty standard with most graphing engines. And then you can zoom in if you want to, zoom in a little bit, and then I will show the images because that's kind of the cool wow factor for this. So you can, these images are taken, these are just thumbnails, so I can actually click on this, and there's sewer. Yay. And you see there's a monitor right here hanging. This is the monitor that does, and there's a ring that goes around the pipe inside here, and that's how, when the water flows over it, that's how you can get a velocity and flow, and those kind of things. And you can just scroll back and forth between these if you want, and it gives a timestamp. So this is every hour. So that's this is what a lot of engineers use just to analyze the data we have that's coming in. And then they can also do some scatter plotting. And an interesting thing here with the scatter plotting is this showing the pipe diameter, 18-inch diameter. And then these circles are these interrogations. So we will send crews out every so often to interrogate, to make sure the monitor is working, or everything's working. And so they go out every so often. And you'll see, yes, there's no current data because there actually is a flow monitoring season, and we're kind of out of that season. So this is data that was just from last year. Flow monitoring season will start in the spring when all the rains come. So we'll start putting more monitors out in the field for clients then. But this interrogation data comes from, we use a field data collection platform called Fulcrum, and they have an open JSON feed, or there's a couple other feeds of data you can get. And you'll see a little bit of Fulcrum here as I do my demo. I'll show you a little bit of that. We're linking to it. But this is a direct read from data that's being collected in that Fulcrum application. And then we also have a time lapse. So you can actually see a pseudo video. I say pseudo because it's just basically images being played quickly in this player. So it's just images being pushed. It's not an actual video. It's just image, 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 image. So it looks like it's actually a video. And you can pause and look at things and see a thumbnail and that kind of stuff. And this is a plugin, I think it's called Supersized. It's a JavaScript plugin. And then we'll come to the map. So originally, the waterspout platform we bought just had a Google map, a simple Google map. But of course, being a GIS guy, one of the first things I said is we need to get rid of that map, and we need to get a real map. And so this is data that some of the data, you see it says Fulcrum flow meters, that's actually coming directly from that Fulcrum platform. And then some of the data is locally hosted GeoJSON files. And then some of the data is services, ArcGIS server services. And it depends on the client. Carl Junction, I believe they do have some services that we're pulling. And you'll see how this map is configured, but this is just a JavaScript API. You can zoom in, obviously, and do the normal stuff. Let me turn off some layers here, because I'll show you a little bit about how the monitors are put in. So I can click on this Fulcrum and the pop-up, and I can view a link of the picture, a top side photo. This is when they install it. This is what the installation looks like. So here's the camera pointed at the flow, and flow is coming from top to bottom. So flow is coming this way, and then you see this wire. That's where the flow monitor is actually in there, and it's recording to this device, and this what gets sent by telemetry by cell signal. That's how it gets. And this is actually bolted to and then there's a big carabiner for all this equipment up here. It's bolted to the top. So once all this is installed, when they go back to interrogate, they don't have to get back down into the sewer, because you don't want to go back in the sewer if you don't have to. So they can just, they take a laptop out, attach the laptop to this, do the interrogation, and then they go to the next one. You can actually, they also do take a video to kind of test the video to make sure that it's flowing. And so this is actually the Fulcrum. You can see the Fulcrum application that we'd use for field data collection. So we're able to link to allow all that Fulcrum data directly. So there's basically waterspout. And not only can waterspout can flow monitoring be done for sewers, but I'm going to show you kind of a unique application that we recently did for if you know what Bennett Springs Hatchery is, basically it's a trout hatchery in central Missouri. And so it's not a sewer, but it's how all the data flows, through the hatchery for the trout. So let's show you. So this obviously is not a sewer, it's fresh water. And the same map. And interestingly enough, just kind of, you saw how it takes a while to load that and to load each page sometimes. The reason that is because this is just loading. This is a big iframe. This loads these pages as iframes. And at first, because as a developer, I have heard the debate whether iframes are good or not good. In this case, I feel they're really good because a user can come in here and actually, let's say they're working with a graph or something like that, and then they want to go over here and work with the map a little bit. They can come back and don't have to wait for the page to refresh and reload itself. So that's kind of a good thing about, in this case, iframes. The user doesn't have to reload the page every time. So, and so in this case, you can see these are the actual raceways for the hatchery. And again, I can click on these and get that installation photo so I can see where it was installed. And I don't see the equipment here, but that's how that, just another example of an application of how we can do flow monitoring outside of sewers. So we'll go back to Carl Junction. And you notice this has the little open dashboard button up here, and the Bennett Springs did not. So there's a bunch of configuration on the background for each of these projects. If I was to log out, I could log into an enterprise side of this. And the enterprise side is where you can configure the monitors, the sites, channels, all sorts of things about each of the projects that you have here. And one of those is the dashboard, and additionally, the other one is the map and where to find this configuration file that I'll show you how I build and how it integrates. So in this case, we'll just open the dashboard. And just to run you through it, eventually when I start it, you'll see we'll have some graphing here, the latest 3 images that the device has taken, some site notes and calibration data. And when and these are visible site notes and calibration because me as a user, when I log into Waterspout, I have admin privileges. If I just had user privileges, I would not see the site notes and calibration. The evolution of this particular dashboard is, as you noticed in Waterspout, it's fairly, it takes a certain level of expertise on flow monitoring to understand the graphing and what you're doing. And there's a little bit of a learning curve, and engineers love that. But for someone else, or let's say you just wanted to know how all the monitors are doing. Are they all reporting? Am I getting data? And those kind of things. So that's why you see this layer has last data from device. And if it, and when this is current, when these are actually running, these should all be green, so they would have current data. But in this case, since it's not flow monitoring season, this is just historic data. That's why they're all red. And our one of our owners said, it'd be nice if we had something where I could just sit and look at the screen after and be able to know that these monitors are working and we're getting data and everything's as it should be. So that's kind of the evolution of this dashboard. So I could come in here and I can set what interval, how often it refreshes, and basically what it's doing is using a set interval function in JavaScript where you can tell it how often to do something. In this case, how often to zoom to the next site. So, and I'm going to do every 5 seconds. I'll just say start live mode. And so you see the latest images come up, the graph populates, and I'm seeing data. Okay, yeah, now I'm verifying that I'm getting data here. And it didn't look like it did anything. There's 2 sites right close to each other. That's why it didn't look like it zoomed, but it did. And I can actually come in here while it's working and say, I want to see depth now. So the next time it refreshes, it changes what data channel is in here. So now there's depth in the chart instead of, and you see there's no images. There's an image problem here with this. So and then I can stop this. And you'll see here's Delilah is actually the name of a project in the Fulcrum Fulcrum application that we've created just to do flow monitoring things, and that's where this is coming from. And then a user actually came in and put some other user notes in here about, you know, if they see something, a problem with the monitor or something like that, they can make a note so we know what's going on with it and that sort of thing. So that was the evolution of the dashboard and why it's important, you know, how it came to be. And then another thing in the dashboard that we wanted to add was the actual, because rainfall and flow, of course, are related. So we added this NOAA rainfall. This is live right now. This is actually a map service that's live. And I have to zoom out to see because there's no rain currently here around Joplin. But you see there's rain across the US and other places. And there's actually a forecast map service also that'll show you a forecast. And I can't remember how, what the time interval, I think it's 12 hours or something like that. I can't remember, but but so those are in there so we can look at that as well. So now you've seen sort of water spout and all these and the dashboard. I'm going to start delving into how some of this actually works. So this data that drives the dashboard, we have a cron job, and if you don't know what a cron, it's a scheduled task in Windows parlance. Cron is in Unix, and waterspout resides on a Unix platform on Linux. And so we have a scheduled task that goes into our waterspout data store, and it's file-based. There's not a relational database. It's just a file-based system, and it pulls data out like last X number of days of data and puts it into a MySQL database. And we're doing that just to make it easier to use the ESRI API, because it's just much easier to do it that way using this ESRI request. And so here's the actual page from the developer's API reference, and I'll show you actually some code now on how we're using the API, or using this. Hold on, I'll drag a window over there in a second. Okay, so basically, these are just code. This is code I copied into a document. It's not actually in an application right now, but so here's how ESRI request works. Here's how I'm using it. So I have a PHP, and I'll show you this PHP here in a minute, here in a little bit, this PHP function. And it looks a lot like, this looks a lot like Ajax. You know, you have to set up what method you're using, some query parameters, what response type you want, and then when you call it, this is called through a function. Then when you call it, you get a response, and then the response is data, and then you can do something with that. And this is actually how I'm actually going into my MySQL database, pulling out data that has coordinates with it, and then actually on the fly creating a GeoJSON layer and loading that into the map. And I found this methodology on the ESRI forum, so it's nothing that I'm doing that I created. So the response comes back from my PHP, that's GeoJSON data, and I put it in this blob, and then I can create the URL from it, and then I use that URL in my, when I construct my GeoJSON layer. And then here's all the properties that the GeoJSON layer has. I'm setting up my labeling, symbology, label placement, all that kind of stuff. And then I do it again because in this particular application, I put it in the overview map, and then I can add my layer to my map, add it to the overview map. And then when the layer is created, I call this so I can zoom into it, and that's what query extent does. These are just a few other things that I'm doing when after I get the data. So in order to get that data, here's just my PHP. I call this MySQL stored procedure, and then I initialize an array, which is actually the start of a construction of what a GeoJSON collection should look like. And so I've got this GeoJSON collection I'm starting. I pull back the data and create an object, which is a collection of the properties. I create my feature, adding in my coordinates right here. And then I set my properties to this array of values that are returning. So basically I'm just looping the row set that gets returned from my stored procedure call. And then these are just, the columns of data that are coming back, because it's just a big array. Then I attach that to push that feature into my overall array of features, and then I return it as encoded JSON. And a note here, it's good to include this parameter in PHP, which basically does this. It encodes all the numeric strings as numbers. So when I look at it on the ESRI, when it gets pushed back and gets created as a GeoJSON layer, I have numbers where I want numbers, because especially for this application, if I want to add, I would do any math on those numbers, I don't have to worry about converting them to numbers. They're already as numbers when they come over. So and I can show you this if you want to see that stored procedure. Not that you're interested. So here's the stored procedure. It's just if you're familiar with MySQL, there's a few versus SQL Server. There's a few differences in some syntax and that sort of thing. But if you've done any work in MySQL in SQL Server, it's fairly straightforward. So this is the stored procedure that pulls back the latest dashboard data, and I can get all the sites if I want, if I send in all projects, or I can just get the project number, just the sites that are on a certain project, if I ask for those. Let's see. So that is ESRI request. Yep, there you go. There's that. And now, is there any questions? I mean, so far, I'll have quite time for questions at the end, so I will continue that. So let's talk about Chart.js now and how I integrated Chart.js. Again, I found a blog post. Thank goodness ESRI is really good about doing that, about how to integrate third-party, integrate Chart.js. And I wanted to use this versus the Flot engine, which is what the waterspout uses, because I think Chart.js is a more modern approach to it. And after working with Flot inside that, I wasn't too hip on it. And Chart.js is a little bit better to use. So how you do it is you have to, since the ArcGIS JavaScript API uses Dojo, you actually have to load it like this to tell Dojo where it is, where your Chart.js is coming from. And then when you call your require, you actually have to put it in there as well. So if you're not familiar with what the require is on the ESRI applications, so let me show you that. So whenever you want to use a certain part of the API, you don't have to load the whole API library in it every time for your application. You can just load the pieces of it you need or want. So in this case, and this is how you do that. So it's a module system. And so you can just load in the modules you want when you need them. But you have to tell Dojo basically which ones you're loading in and where to find them. This is where to find it. And then you can use an alias. And they do have, and that's what this is. So this has to be, the one thing I found out, because I didn't know it had to be that way, the way you reference them here has to be the same order you reference them when you, these are basically aliases. So the GeoJSON layer is the same, is referencing this particular part of the API. And feature layer, and I could call, if I wanted to call that BERT, I could, but so then when I create a new feature layer, I'd have to say new BERT instead of new feature layer. So ESRI does have some recommended alias names standard to use, and they recommend you stick with what they use. So when you come in to use that, so you say new GeoJSON layer. So that matches up with how you have actually referenced it in this function right here. I hope that makes sense to everybody. That took me by surprise, because one time I just kind of referenced a new one in, and I think I put it at the very end, but I had referenced it in the middle somewhere, and I was getting all these errors, and I couldn't figure out why. And then finally I figured out, oh, it's got to be in the same order. So that was just my learning curve with this particular with the API. So anyway, chart. So that's how you can integrate in the chart.js library. I'll show you how you can use that. Sorry. Hold on. Sorry about that. Goodness. So this is basically how you can, and this is when the page is loaded, I'm loading an empty graph, but so you have to create, so here we go. So basically this is, when I load the graph, I'm actually loading it in the response part of the ESRI request. So I have to go get my data, pull it back in, and then I have to create a labels data set array basically, and then some graph data. And there's a lot of good documentation on chart.js, and especially that blog post that I showed you. I basically took a lot of this right from this blog post, which is very handy on how to integrate my, helpful how to integrate chart.js into my application. And then the chart.js documentation is really good too also. So you can create, you create the data just like any other object you're creating. You're adding properties. The data property has data sets, and then you tell it what axis that is and the name of the axis, and then what the data is, just an array of values, and here's the array of the totals. And then you can configure the position of the axes. And again, not being a graph guy, being more of a map guy, it took me a while to figure out the graphing terminology and all that kind of stuff. So, and you just can configure things. And then there's different plugins for Legend, and if you wanted to be able to zoom in on the graph and those kind of things. But again, if you're interested in doing this, just follow that blog post and then go find the chart.js documentation. It's pretty straightforward. So now I will get to the map configuration part. So I'm a big proponent of giving users the tools so they can do something on their own. So the dashboard and the map inside waterspout, and you'll see another application, this rain application that I'll show at the end. They're using the same exact map configuration file to pull data in. And so I created a method that used a big JSON file to tell the applications where to find data, how to configure data, how to do that. So in this case, so this loads in a JSON file that has all this data in it, and I'll show you what it looks like. So basically, it's just the same. It's almost the same objects or properties that are in the JavaScript API. That's exactly what it is. There's a few ones I added in here, so when my code runs and reads this file, I can understand what things are. So I'll show you how the code reads this. So let me show you that. So basically, I use Ajax to load this in, and I'm calling this JSON file, and then I'm just looking at each section. So there's a secure services section that I've added if the services I'm pulling in are secure. But after that, then there's the GIS layers. If you look at that, the topmost thing here is GIS layers, and that's something I've called it. So I'm looping the GIS layers, and then I look at the layer type. It's a feature layer. Then I create a feature layer, and then I grab okay, is it visible? I grab all the properties from that JSON file. What's the pop-up template look like? Is there labeling information? Yes. Okay, how is the render? Then I add that to the map. And I do the same for a map image layer or a GeoJSON layer. So this is the code that actually reads this file. So what this allows your user to do is, if they want to change things, and for the manholes, if I want to say make this red, I can just do that. Now they're red, and then I can save it. As soon as I save it, whatever is reading this JSON file, the mapping applications, it's changed. I can add in whole sections. So if I come to the tree configuration, I can actually copy. And this plugin is nothing I created. This is called JSON Editor. So let me show you that. I forgot. So I found this way to edit JSON, and that's what this is. So I just brought in this JavaScript library to edit JSON in the browser, and I'm applying it to this map. So you can come in here, and I can copy whole sections, duplicate a section, insert things. And you can actually put templates in here. So I've got an insert template for a GeoJSON layer and a pop-up template. And so all a user has to do is come in here and add the layers in, configure them, and then they can actually draw them. Now they have to, when I tell the users, and there's a little bit of a learning curve, because I show them the JavaScript API documentation, this documentation, and say, if you have a, if you want to do something, you want to know what options exist for renders and those kind of things and how that works, here's that resource. But there are a couple other GIS folks in one in our Springfield office and one in our St. Louis office that use this tool. And let's see, the one for, this is an interesting one. So the one in St. Louis, she's actually done some heat mapping that we're going to put in one of the applications. So she's done some heat map rendering. And so this has become a really, because before, when we first started integrating mapping into waterspout, I would actually have to manually create this JSON file. And so then I decided, I want a user to be able to do that and edit that. So the users do. You can actually upload GeoJSON files if you want to use those after you create them. And they have to be. There's a process we've created. We've like a tool in ArcGIS Pro that will create those GeoJSON files correctly. So, and see, I didn't save it, so the manholes went back to green and not red. Oh, I didn't want to show you the cartilage. No, let me draw that. It'll take a few seconds to draw that, because actually coming from Integrity Services, they gave us access to that, so that these services are in their maps. So there is some secure services. There's the username, password, and SKU URL, and then I call the to do that. Let's see. I call the identity manager. So that's what this does. So the first thing it does, it uses the identity manager to actually create the token and register the token and that kind of thing. If the security services dashboard, I showed you this radar. So when we put that in there, I can click on it. If I forgot, I can actually click on it and get information. So I can click on it, and it's a service. So this is about, now I'm going to show you the virtual rain gauge application. And the evolution of that is we put that radar service in the dashboard, and then somebody said, hey, can I click on it and get the amount of rain that's at that point I clicked? And you can. And this map service actually will return these time intervals of rain. And so then the next evolution is that, well, if you can click on it, can I give you a coordinate, and you can actually do that in code and then record that somewhere? And so we thought, well, yeah, we can do that. So I did it. And so that's sort of how the virtual rain gauge application came to be. So I can show, if you want, this is the map service that we are using. So this is the Now Coast map service, and here's all the layers 1 through 72, and you actually have to query, and I'm only querying to record the 1 hour, but you actually have to query the image and then the image footprint, because that's how you get the time. The image layer will give you the actual value of rain, and then the time will actually give you the time. So I have to actually query it twice, 2 different layers. And so as this says, so I've got a scheduled task, a cron job that queries this. It gives a whole list of lat-long coordinate values, sites that we have, and I'll show you the application here in a minute. And it returns you the amount of precipitation. It writes it to our database with a timestamp. So, and here's the virtual rain gauge application. So basically, a user can come in here, and there's different projects. In this case, I'll just show Lawrence, and we've added 5 different rain gauges, and I apply a date parameter. And so you can see there's a rain event. There was a rain event here, the 6th. This is actually live data. And then there's a rain event here, 0.07. So the total amount of rain in the last 2 weeks is only 0.42. So you can, basically this is the total amount of rain, and then the inverted axis is the depth, or the individual amounts. This is a running total, this other one. So if I was to do, let's say, I have one in here that I've had a lot longer. I've got one at my house. And if I was to do, because I put that back there in October, I believe. So if I was to do from October 21, October 1st, and then I was to hit apply date range. So you can see, since then I've had almost 10 inches of rain at my house. So basically what this is just a point that sits in a file, and then every hour it goes out and interrogates that map service using identify, and it grabs the timestamp out of one layer and grabs the amount of rain out of the other. It's mostly zeros, you can see, and then we're able to graph this data and be able to see, this is, again, engineers love this, to be able to do this. Another thing we're doing is we're actually recording images of the radar. And so I've got the time slider in here to actually be able to play that. So if I was to hit play, you can actually see, I have to zoom out. So these are actual images that are being loaded in. This is historic radar. So this is from, see, the time slider is actually changing. This is on the 2nd of October at 8 a.m., 9 a.m., so you see the rain coming in and recording. And I can stop and go back and forth and grab this and just do this. And see, it's moving my tooltip up there in the graph. I've got that synchronized so that the tool, you know where it is on the graph. I will say that these images, this is a hack basically, because even though I pull the image and I actually have a world file associated with it, because when you pull the image, I only pull it, you can see there's kind of a boundary here around the Midwest, because I'm only pulling it for this Midwest area. So the hack for this is, since when they went from the 3.0 version of the API to the 4.0 version of the API, they did not move forward the ability to lay a georeferenced image onto the map. So unfortunately, I have to do this with the picture marker symbol, and I found, again, on the forum how to do that. So actually what this is, a picture marker symbol, and every time the map is zoomed in or out, it resizes that picture marker symbol. You can kind of see how it does it. So this is kind of a hack, and this is the only way to do this in the 4.0 version of the API. But we can put rain gauges. The reason we're all excited about this, is all the engineers are, the water guys, is because it costs money, obviously, to put a real rain gauge in, and then not only that, it costs time and money to maintain it. And because a lot of times bugs will get in there and build like spiders will get in there and do something, or let's say grass flies in to the rain gauge and it stops recording rain. And so there's all sorts of things that can happen to a real rain gauge, and these virtual ones, you can basically put them anywhere. So for those of you in the Kansas City area, if you know what Stormwatch is a set of rain gauges that have been, I think, probably has been in existence for close to 20 years. And we were able to export the Stormwatch locations out and import them into this. So we can actually compare the Stormwatch gauges to what we're collecting. I'm not pulling data directly from Stormwatch right now, but to validate the virtual rain gauge, eventually we're going to do a study that how valid is our virtual rain gauge as opposed to the real rain gauges that are collecting data. So that's why we imported the Stormwatch gauges in there, so we can do that analysis sometime in the future. And then lastly, let's say if I just wanted to add a rain gauge in, and again, if I'm logged in as an admin, that's why I can see this. I just have to come in here and click here, and it collects it. I type in the name, hit add, and then that puts it into our MySQL database into the table. The next time that scheduled task runs, it starts collecting the rain gauge, the rain data for that point. So that's how easy it is to actually put a rain gauge in. So oddly enough, I told my brother-in-law about this, and he goes, "Oh, put one in at my house, because I want to know. I'm always wondering how much it rained in my house." He does have a rain gauge. So here's my brother-in-law's house. And so it's kind of interesting. And then I think another one of our water guys and one of our engineers wanted one at his house, so I put one at Tim's house. So I have Tim's house. So that he can come in here and see how much rain and compare. Because Tim actually has a rain gauge at his house. So let's see. So that's virtual rain gauges. I believe that is a wrap up. So I know I threw a lot at you, and some technical, some not, but are there any questions? No questions?
Looks like we had a couple in the chat. Kyle asked a question. He might have to expand on that. Unless you can tell what he's asking there.
Test those SQL queries in VS Code. Let's see. Oh, I know what you're talking about. Okay. No, you can't. I haven't been able to. So what Kyle's talking about is get that window up. So basically, let me just show you what. So our server, MySQL server, doesn't work like SQL Server, where you can actually save files and easily save them and load them in. So so basically what I do is I just have this document in Visual Studio Code that I record all my SQL statements in, just so I have a record of it, and then I'll just copy and paste, things in here in order to test them, and then that's sort of how I write this stuff. So here's one, actually the virtual rain gauge application, in order to get that data back at different intervals. I'm having to do it. And so MySQL, if you're familiar with SQL Server, you can create what's called a table variable, which is basically a temporary table essentially. And MySQL has the same thing. So I'm creating a temporary table and then inserting the locations in it, the location data, and then I'm actually inserting each of the interval levels in as well, 6 hours, the different, and doing an update to that table. So there are some, you can do the same kind of complicated SQL stuff that you can in SQL Server. You can do the same in MySQL. So is there another question?
There was another question. Can you post the link, the URL link to that chart API blog post that you referenced?
Oh, yeah, absolutely. This one, yeah, this was very helpful for me. I'll throw it in the chat.
And then Bert, I'd also like to get your thoughts on, I know we've got some folks that are attending today that don't come from the computer science background and are coming from the GIS background. What do you recommend if somebody wants to go this direction? What language, do you think there's a good starter language? Is JavaScript the place to start? What advice would you have for folks that are interested in doing this, but didn't come from the computer science angle?
So I would come JavaScript, and I'll tell you, the documentation Israel gives, there's so many samples and the references are really good. So let's say, for example, you just want something where I just want to know how to put a map in there, or something like that. You can just type in, some kind of a, how to do things. And so how to do basic things, and it gives you code samples, and then you can just start from there. what I'll do is I'll come in here and I'll say explore in sandbox, and then I'll copy and paste some things out. Actually, when I first started looking at this API, I created a blank HTML page and I copied verbatim one of these like this, pasted it into my HTML page, and just started playing with it to figure out how everything worked, and then just started adding to it. So that if you have a way to do that, that's what I would recommend. That's kind of how I started with this, and I only started doing this heavily, the ArcGIS JavaScript API, probably a year ago. But again, I have a extensive background in programming and JavaScript itself, so it wasn't it wasn't too difficult. The Dojo part for me was because I wasn't familiar with Dojo, and I have integrated Dojo. So all these panels here in these are Dojo objects that I'm using, and these panes, and then this table, I think, is a grid, Dojo grid, I think it's called. That's a Dojo object. So I'm having, I was a jQuery guy, but I'm having to learn Dojo a little bit as well, because that's what the ESRI JavaScript API is based on. So. But don't let the vastness, and it's pretty big, the API itself, deter you from getting into this. Because you can see there's again, like all ESRI stuff, there's a lot there. But start with the basics. But JavaScript would be the one to start with. Yes. Is there any other questions? And yeah, what I'm showing here, sorry, is Visual Studio Code actually is what I'm doing. I do use Visual Studio, but I found for this particular, even my PHP, I use Visual Studio Code for my PHP stuff. So it's really good. One thing I forgot to note is, so what's really interesting about this particular this plugin, if you have a problem, it has a syntax checker. So if you don't have it tells you exactly what the errors are if you don't have things correct when you're editing this JSON. So that's kind of a thing that for somebody who's going to be using this, that was kind of a really good aspect of this. So if you're interested in this, you doing something similar, this plugin is really good for that, this editor.
Okay, I'm not seeing any other questions in the chat, so I'll do a last call while I wrap things up. I'd like to thank Bert Meyer, Trek Design. That was a fantastic presentation. It's nice to have something a little more technical and deep dive for folks that are interested in that, and neat to see those videos and all your hacks and all that kind of stuff. So we appreciate that a lot. Thanks to everyone who attended today. We really appreciate your time. Just a quick reminder of the Educational Needs Survey. Link is in the chat. And if you would like to give a Lunch and Learn presentation, we would love to have you. Send us an email at kamappers@gmail.com, and we'll be in touch. So
and I accept, if you guys have questions, here's my email address. Just email me, and if I can answer it, I will.
Fantastic. Thank you so much, Bert.
Sure.
And we'll call it a day.
All right.
All right.